Hi guys, Nexi here, back with another video, and today we're gonna review another 3D printer. This time it's Creality CR-10 Smart. Stay tuned. Welcome guys, and thanks for tuning in. I have tested and reviewed many Creality 3D printers on this channel, starting first from the CR-10S back in 2017, which was very impressive and affordable large-scale 3D printer. Since then, Creality has released many more 3D printers of the CR-10 line, and now we have the latest model in 2021 called CR-10 Smart. CR-10 Smart is interesting 3D printer and it looks promising when you look at the price, specs and features, as this machine comes with the same large build volume of 300 by 300 by 400 mm, just like the other CR-10 3D printers. This machine has auto-bed leveling, 32-bit motherboard with a silent stepper drivers. There is a Wi-Fi connectivity, internet and USB port so that you can print models remotely and monitor printing over the camera. CR-10 Smart has a frame that looks really nice, as design is inspired by sports car, probably a Lamborghini. The printer has nice and responsive high-res touchscreen with a simple layout interface, which is very easy to use. Extruder is a very well designed and it's easy to install the filament, and this extruder works with all types of filament, including the flexible one. This 3D printer has a metal frame, very stable, and dual Z-axes are synchronized with a belt and reinforced with a dual bars. Next, we have the auto power off feature, which can turn off the printer after printing, which is very useful. There is a filament runout detection and nice spool holder that can fold to the side. We have a belt adjuster on both X and Y axes, and there is a built-in drawer compartment for the tools and accessories. So far so good, and the CR-10 Smart seems to be a very good 3D printer. But let's dive a bit more deeper, starting first from unboxing and assembly. The printer comes very well packed and protected inside the shipping box, with a lot of foam so nothing was damaged in the shipping. Once you take everything out from the box, you will end up with the upper and lower frame part, Z-axis reinforcement bars, filament, LCD screen, screws, spool holder, spare Teflon tube, spatula, power cable, user manual, and some stickers. The assembly process is easy and straightforward. Once I place the upper frame part on the base frame, I screw down 2 screws on both sides with a supply tools that was hiding in a drawer in a printer base frame. Next up was the Z-axis bars, which holds with the 2 screws, one on each side. Upper screw don't need the washer, but the lower one does, so make sure that you place the washer on the correct spot, like I show it here on the video. Once I install the spool holder, I plug in the power cables for the upper selection of the frame, and I plug in the both stepper motors for the Z-axis and the optical stop switch. Next, I plug in the LCD and I click it into place. I plug in the main cable and I check every bearing wheels on all axes. Then I install the filament that comes with the printer and I peel off the plastic foil of the heated bed, LCD and the SD card. At this point, assembly was complete and it took me around 12 minutes, so this printer is beginner friendly. Next up was the installation of the Creality Slicer software, which you can find on the SD card. More on the SD card was a digital copy of the user manual, drivers, precaution of the start G-code that you should use, troubleshooting, some G-codes of the different 3D models, and the operational video. The Creality Slicer, which I used many times in the past, is basically just a skin version of the Cura. But indeed, it works pretty nice with the CR-10 Smart, and I found that the print quality for the most print profiles was pretty good, except the temperature and the retraction that needs some adjusting. Before I start the first print, I started the auto bed leveling sequence, and await the printer to complete the probing. Basically, the printer will take 16 measurements of the different part of the heated bed, with a built-in sensor inside of the print head, and use these values to compensate the Z-axis movement later on during the printing, to get a perfect first layer. That sounds great on a paper, but in reality I found this process to be really slow for some reason, and it took over 5 minutes to complete the task. Thankfully, you don't need to repeat this process again for a long time. The first test print that I tried was a G-code of a dog that was on SD card. During the printing I took a dB meter and I measured the noise level. While the stepper motors and the power supply fan was indeed silent, the cooling fan inside of the printhead was definitely not, and the noise level was around 47 decibel, which is a decent score for a 3D printer, but is definitely not silent. And it's a shame that Creality did not use silent cooling fan inside of the printhead, as the noise level without this fan could easily go under 38 decibel mark, which would be great. Now the print quality with the supply PLA filament was decent, except for the retraction, which needs adjusting as the stringing was showing on a printed model. I try out to reuse the white PLA that comes with the printer, and I print out some shower rings that I needed for the small bathroom in a basement. Again, even with my adjusting, the stringing was still present on the prints, but our print quality overall was decent. So I start with the retraction tuning again, but I could not get better results with the supply PLA, no matter what I do. So I just installed a better quality PLA filament, and immediately I got a better results even with the stock print settings. I found that retraction distance of 4.4 mm with a retraction speed of 120 with a combination of 195 degrees on a hot end give me best results for this type of PLA. So I print a few 3D benches. First one in 0.2 mm layer height, next one in 0.15 and the last one in 0.1 mm layer height. All 3D benches was printed with a speed of 50 mm a second. The print quality was overall pretty good, but not the best. Overhangs was good with almost no stringing. Top and bottom surface finish was great, but there was some imperfections on a printing surface because of the seam. Right here where the next layer start was too much visible on the printing surface. This can be fixed using the different slicer or just playing with the Steam settings. Next up I found some cool looking battery holders who look like a beer crate, and I print a few of them for all type of batteries that we use in a house. I found these battery holders to look really nice and they are very useful. Print quality was good overall, but some stringing was still present despite tuning and lowering the print temperature. So I just use a heat gun to clean them. For my next print I installed some orange color PLA and I print out this impeller in 200% scale. This print on other hand turned out very nice, and the print quality was on spot this time. I just realized that I forget to print FDM benchmark test print that I print usually on every 3D printer. So I slice it and I start to print. It was nice to see that on my every print the first layer was pretty much perfect, and later during the printing everything seems to go pretty nice. But when I return close to the end, once again the stringing was back, which is strange as this is exactly the same spool of PLA filament and the same print settings that I use to print 3D benches. But nonetheless, the print quality except the obvious stringing issues was very good. None of the pins was stuck and I was able to free them with no effort. Print surface was great, ringing was minimal, bridging was good and overhangs was good too. Except for some weird movements here, but that's the slicer to blame. Also the print accuracy was close to perfect. These stringing issues I could not work out, so I just moved to PETG at this point. My first print with a PETG was a tripod holder for my GoPro camera, as my old camera holder broke, so I needed to print the new one. During the printing process I did not see any stringing, which is weird as PETG loves to string. In the end, the print turned out very nice, much better than with a PLA, and the print fits perfect on my GoPro camera. Next print with this blue PETG was this Spire Tower, who also turned out great. The print came out with all small details, with a nice print surface, which is nice. Next I installed the silver PETG and I print out this spiral vase, who really turned out great. I completely turned off the filament cooling fan and the layers bonded so nice with this PETG that you can't even say that this vase is 3D printed. And the print quality was perfect. Really nice print. Next I want to print another vase, but this time in a maximum size that the printer can do. I let the printer to work overnight and in the morning the print was finished and the vase turned out pretty much perfect. This is a really nice print and I like it a lot. There was no imperfection, a really nice print and I like it a lot. Now the last two test prints was with flex filament and ABS. So I print out this quadcopter arm, first in a flex filament and then in ABS. Print with flex filament did not turn out the way that I expected, as once again I had a problem with the stringing, so the print quality was not the best. While the ABS print, on my surprise, turned out perfect, from the first layer all the way to the end. Layers bonded nice and even, no stringing or warping, it was a perfect ABS print. Now the next test is the heat bed warm-up time, and here is the results. The CR-10 Smart hit 60 degrees in 4 minutes and 70 degrees under 6 minute mark, which is a decent heat up time for PLA and PETG printing. But for ABS printing, the heat bed temperature of 100 degrees was reached after long 18 minutes, which is a shame as this printer performs very good with ABS. The reason for this slow heat up time is mostly because that the CR-10 Smart don't have the heat bed insulation installed under the heated bed. So if you have this machine and you're planning to print a lot of ABS prints, I recommend that you install heat bed insulation, which will significantly speed up the heat up time. Now, the few words about connectivity and the smart features. This printer has indeed a built-in Wi-Fi, which lets you to remotely operate the printer from your smartphone, but the Creality Cloud app was not that useful in my opinion, as there is no way to tell when the printing is started or how it's going, as on the USB port on the printer, you can only connect the webcam from the Creality itself. So I mostly use the Creality slicer on the PC with a Creality plugin. That works as it should, and I was able to slice the model and send G-code file directly to the printer over my home network. During printing, there are a few features that you can activate, like a filament runout sensor, power out gauge, and the auto off feature, that I found really useful. But keep in mind that the power out gauge function only works for short periods of time, as this glass bed self-releases the print when it's cooled down, and even if power comes back fast, the print that you continue later on will not look perfect either. So I will not rely on this feature too much. And now, the final words. The CR-10 Smart could easily be the great successor of the CR-10 line 3D printers, but right now it's not there yet, mostly because of the firmware that runs this machine. Even the latest firmware that I installed later during my testing still did not improve the speed of the homing, filament feeding, auto bed leveling, and even the printing. Everything is just too slow. The issue with the retraction that I had during my testing was probably more related to the wrong temperature reading on a temperature sensor inside of the hot end, as this printer tends to print with a much lower temperature than any of the Creality machines that I ever tested before. This looks to me more like a sloppy PID tuning in a firmware than the hardware issue. Also, I gotta mention that the advertising auto bed leveling doesn't seem to work properly either, as you can clearly see that the nozzle don't keep the same distance from the glass bed during this virtual print, which also led me to believe that the auto leveling feature are not optimized or not even activated in a printed firmware. I also tested the latest Creality slicer and the latest firmware, but this problem was still present. Thankfully, I did not print some large models with a large bottom surface, so I did not have problems with the first layer during my testing, but this problem for sure needs to be addressed. Either so, all of the complaints that I had with this machine are mostly related to the printer firmware, and I hope that the Creality will address this issue and fix them in a future firmware updates. That will make this machine so much better, and the CR-10 Smart will then be a true successor of the CR-10 line, but sadly right now, it's simply not. Alright guys, I hope that you liked this video and found it useful. If the Creality fixed these software issues, I'll be more than happy to recommend this 3D printer. But until then, let's wait and see what happens. If anything changes in the future, I will let you know in the comment section. Until then, I wanna thank you for watching, and I see you next time. Bye bye.